Hi everyone, this video is to show you how to use the Ptolemaic Model Simulator or Ptolemaic System Simulator. I have a link to the website which contains it in your lesson, but I also have it included in the free materials at the top of the list of lessons along where the table of houses is and other tools. I want to show you how to use this using the parameters that are in the lesson. So I have on the left, I have the lesson material. We'll fill in the parameters and then we'll get rid of the lesson so that we can see a large version of the simulator. And we're going to start with Mars, since I used Mars as the example in the lesson. Now you'll see on the left that we have the parameters, which is really all that you need in order to create a working Ptolemaic model of Mars. We have the size of the epicycle, which is proportional. It's not a distance in miles. We have the eccentricity, which is how far off center his deferent is. His rate of motion, that is how much he moves on average every day. And where the apogee is. And we'll use the apogee from 2020, which is 150.5. Now, if we look over on the right, you'll see the model simulator. And it's preset to have Mars showing. And if we look at the pull-down menu, you can see we have Venus, Mars, Jupiter, and Saturn. And that's because these are the 4 planets that use this same model. The models for the Moon and Mercury are very different, and I don't even know if there is a simulator for those. So we'll just stick with these 4, and we'll pick Mars. Now we see here that they have calculated the epicycle size as 0.66. That matches the lesson. But if you wanted, you could make it smaller. You could invent a planet with a larger or smaller epicycle, but we'll use Mars's. We have the eccentricity. Again, you can use the slider to invent a planet. The motion rate is the same as the lesson. The only thing that's different is the apogee angle. They have it at 106 degrees, which I guess would be 16 degrees Cancer. I'm not sure why. Maybe that was where the apogee was in antiquity. But today we're going to make it the modern apogee, which is 150.5. And this will give us our model. So let's now go full screen on this, and I'll show you around the model. Here we have, in the big picture, we have the sun on the outside, and the sun is going to start moving through the zodiac. And then we're going to be able to follow Mars, which is the little red dot, on his epicycle, and we're going to see how it can be viewed from different perspectives. Now down at the bottom, you can see that they've got a little S for the sun and a P for the planet, and it's going to track the degrees through the zodiac in an ongoing way. Now, over on the right again, we have some controls. Actually, let's go down to the bottom right. What we have here are some keys to what the symbols mean. The blue dot is the Earth. That is the center of the universe. And here you can see it in the big picture. So that's the Earth. Then we have the red dot is the planet, in this case Mars. The yellow dot, of course, is the sun. The purple dot is the center of the planet's deferent. So this would be the center of Mars's deferent circle. And then the green cross is the equant. That is the place in outer space where if you measure his daily motion along the deferent, it will be in equal amounts at a constant rate every day. So you can see here that in the big picture, the green cross, the equant, is about equidistant on the other side of his center of his deferent as the Earth is. So that's exactly how Ptolemy described it. Now we can choose some things with the animation. First, we can choose the animation rate. We're going to slide it over to the far to the left and make it go very slow for right now. And we can decide what things we want to show. If we didn't want the deferent, we could take it out. If we didn't want the epicycle, we could also take that out. We can show the equant vector, and that shows you how it would look if you were in a spaceship from the equant point of view. So as it goes from the equant to the center of his epicycle, and it's going to track around. And we could also show the planet vector from the Earth. That is, how it actually looks to us from Earth. This is his true position. So for example, in this case, if we're on Earth and we're looking at the body of Mars, he is in early Aries. But as we might look at it from another perspective, he would appear to be in a different degree. So this line shows the true position of Mars as seen from Earth. We can also show the line from the Earth to the Sun, and we can show the little line inside his epicycle. Let's just look at his system for now. And we can, this path duration slider will track, or it determines how long we want to track visually his motion. Let's put him in motion and we can see what happens. Okay, let's slow this down a little bit. Now you can see that he is slowly moving around his epicycle and tracing a line. And the center of his epicycle is also moving at the same time. You can see he's moving on his epicycle at a different rate than he moves on the deferent. That's because his retrogradation period is short, but it takes him about 1.88 years to go all the way around. So if we follow the sun, we can see that the sun is now close to 3/4 of the way through the heavens, or through the zodiac. And let's speed up a little bit and bring the sun back to 0 Aries, where we began. And you can see that in 1 year, as the sun has gone around, the mean position of Mars, the middle of his epicycle, has only gone around half of the circle. And we can also see that he has slowly, as he's moved around the epicycle, he's beginning one of his retrograde loops. So let's see how that looks. Let's speed it up. Now you can see that even though his epicycle looks really big, the model is structured. Let's move, there we go. The way the model is structured, his retrograde loop is not that big. You can also see that he has now returned to early Aries in just under 2 years. So remember, the mean, the tropical period of Mars is 1.88 years. So in just under 2 years, he's now back at the beginning of Aries. Now, if we speed this up, we can start to see. Let's make the path last a little longer. So there he makes a little loop. And he makes another, he's about to make another loop. And these loops will not always be of the same, they will not always appear the same. See, that loop is a little bit bigger than the other 2 loops, and that's just a function of how his system works. Now let's change this a little bit so that we see his true position, how he looks from our position. So you can see where he is tracking versus the sun. And let's also notice one other thing. You notice that the superior planets go retrograde at certain distances from the sun. Mars starts to retrograde about 90 degrees from the sun. So here we have what would look to us as a Sun-Mars conjunction, because as we see it from the Earth, the Sun and Mars are roughly in the same place. We would also call this being under the rays of the sun, because he would be invisible to our eyes. Now let's watch what happens as the sun gets farther away from him, and let's see when he would appear to turn retrograde from our perspective. Still moving forward, still moving forward. Now he slows down, you saw. He slows down here, and now he's about to turn retrograde. That's a little more than 90 degrees. It's about 90 degrees to 120 degrees, depending on the part of the zodiac. So now we'll see that his position will now move retrograde. There we go. And then he moves direct again. And then the sun catches up to him again, and he will be under the rays again, right about there. So this is the basic way we can use the model simulator to see how the model works. And in your homework, you will be programming this for Jupiter, adding in the parameters for Jupiter, and find a position, or find a screenshot in which the Sun and Jupiter in one of your charts matches the simulator. And that should be pretty easy, because Jupiter only moves through one sign in about a year. So it should be pretty easy to find a time. Let's give an example of that. Let's go to Jupiter, and we will get his parameters. His epicycle size is 0.19. His eccentricity is 0.04. His motion rate is 0.08. And his apogee is 273.2. Oops. Okay. Now let's look at the Jupiter model. You can see that his epicycle is very tiny, and he's going to move very slowly. Let's just give a nice example of that. See, the sun goes almost all the way around the zodiac before Jupiter even can go through one sign. So suppose that your sun was in early Gemini, and your Jupiter was in, let's say, late Virgo. We could start the animation and go a little faster till we find this line of his true position, get to around late Virgo. Okay, let's see. He's getting close to late Virgo, but the sun is still, has already passed Gemini. So let's see if we can, let's see what happens if we can. Okay, that was almost it. We're still into Libra. We might have to let Jupiter go through the zodiac a couple of times until we get the right position. But it shows you how we can change the models and simulate what we see in an astrology chart.